Okay, welcome to video 5.1. Here we're going to be talking about solving a systems of equations graphically. So what is a system of equations? System of equations just means that we have more than one equation and more than one variable. So our solution to systems, those are always points of intersection. So remember that those are written x comma y. So our number of solutions will change. Sometimes we can have exactly one. That means that we have two lines that intersect at one point. And an example might be something like this. And you can see here that they intersect at one point. So this one point of intersection would be my solution. So we can see it right here, one point where they intersect. And that happens when the equations have different slopes. Then we can have infinite solutions. That means that the two lines are right on top of each other. And this happens whenever we have two equations that have the same slope and y-intercept. They're the same line. The other case that we can have is when there's no solution. And that happens when we have two lines that do not intersect at all. And this happens whenever we have two lines that have the same slope. So those are our three options. One solution, infinite solutions, or no solution for lines. So the procedure for solving equations graphically is that we first graph each equation on the same set of axes. So it's no different than what we've already been doing. We're going to graph each equation. They're just going on the same set of axes. And it might help to use a different color or highlighters to help identify the different lines so that you know which one is which. Then we always need to label the equations because there's two different things in this graph. I have to know which one is which. And then identify the points where the graphs intersect, if any, and those are your solutions. So we're looking for points of intersection. But remember, from above, they might intersect once, they might intersect infinitely, or they might not intersect at all. And then we write the solutions as an ordered pair in parentheses, and they're always x comma y. And then we can check our solutions. Okay, so let's look at this example here. The first one says, find the solution to the following system of equations graphically. The first one's already in y equals, and so is the second one. So I don't have any work to do there. Now I just need to graph each piece separately. So I'm going to start with the y equals negative 2x plus 8. I'm going to first identify the slope and the y-intercept, and I'm going to write those down. So I've identified the slope and I've identified the y-intercept. But if I look at my graph, well, I can't start at the y-intercept of 8 and go down to right 1. So in order to offset this, and I did this on purpose because I know we're reluctant to go to our calculators, we can go to our calculators. We can put this in y equals, and then I can just get a table of values so that I do find the points that I can graph on this 5 by 5 graph. So y equals negative 2x plus 8, then go second graph to get the table, and I'm going to write down points that I can actually put on this graph here. So I just copied on the table, and now that I have these points, I can go ahead and plot them and connect them with a line since it's just an equation, no inequalities. And I actually wrote more points than I needed to. I can't graph all of those, but that's okay. I'm going to leave them even though I can't graph them because they are points on that line. And now I'm going to connect with a straight edge. And because there's nothing restricting my domain, I can put arrows on both ends. But then remember that we also need to put a label because we have more than one thing going on this graph. So I suggest using pencil, but then if you want to highlight, you can. I'm going to write the equation on that. Okay, so now I've graphed that one. Now I'm going to move to my other equation. So I wrote m equals 1 and b equals 2, so I can actually use slope y-intercept for this one. So now I've plotted my points and I connected with an arrow on both sides because there's nothing restricting my domain, so I can continue in both directions. And then I'm just missing a label. Since we have two things on this graph I absolutely have to label, so I'm going to put y equals x plus 2. Okay, almost there. Now I've done all this lovely work, but I haven't actually found the solution yet. So what is the solution? Well, we already talked about the solution is the point where they intersect. So if I look on my graph, the point where they intersect I can see is right here. So you can circle it, you can highlight it, whatever you want to do, but this is the point of intersection right there. So now I got to write that as a point in my directions. It says where the solution is an ordered pair in parentheses x comma y. So my solution is 2 comma 4. And I'm not quite done yet. Now I just need to do my check because that's the last step. So to check at this point, we're going to just check by if we would know if it's a solution or not, if we can sub it in for x and y and get the same answer. And we have to check it in both equations. So for the first one, I subbed in 2 as the x, 4 is my y, in place of x and y. And don't just guess and assume that it'll work. Put it in your calculator. So 4 obviously isn't going to change. Negative 2 times 2 plus 8 does give me 4, so that does check. And then we can try the other one. And my check shows that that works too. Okay, we'll continue this in class.
Who's going to get an 85? Put him in a
Robert.
Put him in a